removal, you can use that to confirm proper engagement now. Failure to fully engage can lead to severe damage to the torque converter drive hub or the pump itself.
That's a lot of potential pitfalls to avoid. Now, turning to the friction and reaction units, specifically the hydraulic clutch pack assembly, what are the critical inspection points there once it's disassembled?
First, keep all parts from each clutch separate to avoid mixing them up. Cleaning is vital. Ensure components are free of varnish residue, burned disc material, or metal filings. Pay special attention to the hub splines. They need to be in good shape without rounded corners. Test their fit with a new clutch disc. If it binds, that component needs replacement. The clutch's hub splines should allow the new disc to move up and down freely. Spring retainers should be flat and free-floating, and all springs must be checked for correct height, cracks, and straightness. You'd also closely examine the Belleville spring for signs of overheating or cracking.
And the steel plates and friction discs themselves?
Steel plates need to be flat and not worn too thin. Check them for spot scuffing or bluing, which means discard, though some discoloration is okay if the plate isn't warped. Warping is checked by stacking them. Gaps indicate warping. Some plates are slightly dished or waved designed internally to cushion the application feel. Remove any polished surface finish if plates pass inspection, and check for damaged drive lugs. For friction discs, you're looking for signs of wear similar to bands, no chunking, flaking, or burned surfaces. Discs stripped of facing material have been overheated or confused to steel plates, locking the clutch engaged. If the discs don't show deterioration, squeeze each disc. If fluid comes to the surface, it's not glazed and can hold fluid. If it's charred, glazed, or heavily pitted, it needs replacing. A black line around the center of the friction surface also signals replacement is due.
The phrase clutch pack clearance is critical really stands out. Why is this measurement so important, and how is it adjusted?
It's critical because excessive clearance leads to delayed gear engagements, while too little clearance causes the clutch to drag. Adjustment is typically done using selective components of varying thicknesses, like snap rings, reaction plates, or custom steel plate thicknesses. If clearance is less than specified, use thicker selective components. If it's too great, use thinner ones. You can measure clearance with a feeler gauge between the pressure plate and the outer snap ring, or between the backing plate and the uppermost friction disc. If a waved snap ring is used, measure to the wave farthest from the pressure plate. A dial indicator with a hook tool can also be used to measure how much a disc can lift.
Understood. Now, the one-way clutch assemblies, the text says they're purely mechanical and relatively simple to inspect. What are we looking for there, and what causes their failure?
Their simplicity comes from being mechanical, but their durability hinges on constant fluid flow. If one fails, fluid starvation is often the culprit, so inspecting the hydraulic feed circuit is crucial. We check the rollers and sprags, which ride in an overrunning state. Sprags create a fluid wave, making them slightly more resilient. Rollers tend to throw off fluid, increasing risk during starvation. For roller clutches, check rollers for a smooth finish, races for burnelling, and springs for cracks or flattening. Sprag clutches require a thorough external inspection for damage to the sprag faces. Scored or torn faces indicate dry running and require unit replacement. Also, check that the feed holes in the races are clear using a small wire and cleaner.
Installation seems particularly important for these, given they dictate power flow.
Absolutely. It's critical to verify the direction of lockup before installation. Installing a one-way clutch backward can cause significant drivability problems, like locking in the wrong direction, leading to unexpected engine braking or freewheeling in the overdrive range. A buzzing noise in a specific range can signal a problem in either the holding or overrunning mode. Understanding power flow is key for correct assembly.
Finally, let's touch on bands and drums. How have modern transmissions changed the way we inspect these? And what are the signs of wear or damage?
Overdrive automatic transmissions now often use a band in the overdrive cruise range, which puts additional stress and accelerates wear. You'd look for chipping, cracks, burn marks, glazing, non-uniform wear, or flaking on the friction material. Similar to clutch discs, squeeze the lining to see if fluid appears, indicating remaining life. Inspect associated parts like struts, levers, and anchors for wear. For drums, check for discoloration, scoring, glazing, and distortion. Cast iron drums can generally be restored by sanding with 180 grit paper, but a polished surface is undesirable. Stamped steel drums are prone to dishing, which distorts the band and weakens the friction material's bond, so a dished, stamped steel drum should always be replaced.
It's clear that automatic transmission work demands an incredible eye for detail and adherence to very specific procedures. There's no room for guesswork, only precise measurement and inspection. Share this episode with anyone interested in the intricate mechanics of automotive transmissions.